Hey guys, welcome back to Tech Samadhan. So we have started with the machine learning series and hope it would be useful for all of you after completion of Python. Till now we have covered like what is machine learning, the algorithm which is supervised and supervised, and the different types of algorithm used in supervised learning. And basically two main types in supervised learning which were classification and regression and the algorithm used for them. Now this is the other algorithm which we will see in this course of video, which is k nearest neighbor, also known as KNN. We have seen the linear regression, logistic regression, which is a part of regression algorithm. Then we saw decision tree in the previous video, which is a part of both logistic with like regression as well as the classification. Now we will move forward with k nearest neighbor, and also this is used for both classification and regression. You can have some information about KNN and how it works, or basically the steps for that algorithm. You can have a look. And one thing important here, that here we calculate the distance. I will also explain this like in the course of machine learning in engineering colleges. There are numericals which definitely comes in exam. So we have got you covered. This is also explained in this video. So please watch till end. So these are the common metrics we use: Euclidean, Manhattan, and Minkowski. So I will use the Euclidean distance for the example I will show you. Now we have the coding example as well as I said numerical example. So ever wonder why or how Netflix recommend us movie or Spotify suggests song that we like? So this is because of KNN algorithm. So KNN is one of the simplest yet most powerful machine learning algorithm used for classification and regression. So in this video we will explore how KNN works, when to use and how to implement it in Python and with real world example. So moving forward, we can imagine this as we are in new school and want to make friends. So you see a group of kids playing basketball, another group playing a football. You probably join basketball if most of your old friends used to play basketball, right? That's how KNN works. It looks at the nearest example, or we can say neighbors, and predict what most likely based on the majority. So KNN is supervised learning algorithm used for both classification and regression. So as in classification, discrete values, and regression, continuous. This is a basic difference between the both, as you know. So here, how does this model will work? So first we will find k closest data points or neighbors, like we say number of friends playing basketball and football. So that is the k closest data point. Looking at their labels for classification or values for regression, assigning most common label or average value to new data point. So we basic scenario is that we have been given a data point and we need to see whether does it fits. So based on the k nearest neighbor or the behavioral type, we will classify it. To the nearest neighbor, it would fit the new data point. So there are basic steps about how algorithm works. I will show you it here. The first is we need to choose number of k's. So what is k? So there are some common values which are predefined: 3, 5, or 7. So common values are 3, 5, or 7, which we can choose. In order to avoid types, we use the odd numbers. We will prefer the odd numbers, and if anything is not given, we will use 3, 5, or 7. And if the k value is given, we'll have to use that particular value. Then we need to measure distance between new data point we want to classify and the existing data points. So here we will calculate that distance. Using these three methods, any one of that can be used. So commonly used is Euclidean distance. Then we will find the step 3. As you can see here, we will find the k closest point to new data point. And in the last step, we will classify that data point based on majority label. So we will see the classification example. Here we are creating a KNN model to classify if a fruit is an apple or an orange based on its weight and size. So see, here we are going to classify the fruit like some XYZ fruit is given to us, and we need to classify it whether it is orange or apple. Now with the nearest neighbor we will do that. Now here we are going to import our numpy. Now why this numpy? Numpy is basically used for numerical Python, and it's very important library in the machine learning, and I will definitely explain you this in the course of video in the upcoming videos. we have imported the k neighbors classifier class. You know now how to import it. Okay. Now you can see here. See, default is 5. What is 5? For the k nearest classifier, the default value for k inbuilt in the model is 5. As we saw, odd numbers are preferred there over even number to avoid ties. Then, as we did in the previous examples, we created and trained that model. Now see here, but it is default 5, but here we have used our k as 3. We have used k, we have used k as 3. What does it mean? We have used 3 neighbors. Then we have did the model fitting within x and y coordinates. Then we will predict for new fruit, whether it is the apple or orange. Okay. Now the new fruit has the features and levels or the weight and size as 160 and 7. We need to predict it for new fruit. Now we will see, we will run our code, and what does our code predict, we will see. So yeah, it took time, but definitely it processed and it predicted that our new fruit, or in technical terms, the new data point, is classified in the category of apple. Now it used its 3 neighbors to check. So the model checks 3 nearest point. If most neighbor are apple, it will predict the apple. See 150, 140, and we have given it as 160. Now most in that range it is apple. So it has predicted apple. If most neighbor are orange, it will predict orange. Okay? Hope you got it. Now it can be used for some spam, non-spam email for use cases for KNN classification. Now moving forward for regression example, we will clear this out. Now KNN for regression, it is used for continuous value. So here we are creating KNN model to predict house price based on size and location. Now this is we have imported k neighbors regression. So regression based on k nearest neighbor. Here also default is 5. Here we imported k neighbors classifier. Here regressor. So this is the main difference you would see in this example. Yes, the data are also different, but the imported library is also different. Now this is our data we took. Now we created that model. Now here we have trained our model using only 2 neighbors. We defined it, 2 neighbors. Now 1603, we need to predict the price for our house. Now we will see what does our model predicts with 2 neighbors. It predicted some of these values. Hope you can see that values. This is it, the value it predicted. So it predicted 350, comma, yeah, it predicted this. So what did it did now here? It used its 2 neighbor to find 2 closest house based on size and location score. So the model find 2 closest house. It predict the price as average of neighboring price. How did it predicted the price as average of the neighboring price? So for classification, you saw how it predicted, and like in the majority, and here on the average. And use for case for KNN regression is sales forecasting, customer lifetime value prediction. So things to keep in mind for k nearest neighbor is we need to start with k3 or 5 most common. Smaller k, if we have some smaller k, then smoother decision boundaries and more sensitive to noise. High variance with larger k, smoother decision boundaries, low variance. So best practice we need to remember, we will have to use odd values of k if anything is not given to avoid ties. So yeah. So as I say, I will explain you a numerical part also. for KNN problem. So here we have been given an instance 6, comma 8, and we need to find whether the student is passed or failed. Now see here, the table has marks for science and maths, and the result is the target value. Now here the case predefined or given to us as 3. So we'll use the 3 neighbors, nearest neighbor, to classify our this point 6, comma 8 either in fail or pass. So as I said you, there are numerous distance formula we can use, but we will use the Euclidean distance. So the formula is square root of summation of y minus x whole square. Okay. Now we'll calculate the distance. So it is 6 minus 4, 8 minus 3, root of. So it's 29, 5.38. Similarly, root of 1 we calculated for each and every data point with this instance point. You can see here. Now we arrange this in descending order. So it's 1, 1, 2, 3.16, 5.38. As you can see, we have sorted this in ascending order. Then this 112 we have took this 3 instance because k is 3. We have taken 3 nearest neighbor with smallest distance. Okay, keep that in mind. Because k is 3, we have took the 3 distance. If k is oh, see here, k is 5, then we need to take all that distance. But they have given us before and k is 3, so we will use this 3 nearest neighbor with smallest distance. Now this 2, 3, 5 are nothing but the serial numbers, as you can see here. This 2, 3, 5. And see that 2 corresponds to pass, 3 corresponds to pass, and 5 also corresponds to pass. So with that Euclidean distance also pass, pass, pass. So our new instance 6, comma 7, based on majority, we have predicted that it falls in the pass target or result category. So the student with 6, comma 7, I guess instance, has been 6, comma 8. The target value is now pass. So hope you have got you covered with the coding part, the algorithm, as well as the numerical part, and how does it work for both classification and regression. In the day, so if you found this helpful, just like, subscribe, and comment KNN Master if you made at the end. Thank you.